All right, my friends, we're working on absolute value inequalities now. And so I've created a little chart for you guys up here just to show you the breakdown of how these work. And so there's three types of problems that you could encounter in this lesson. There's ones that have an equal sign. There's ones that are greater than, and there's ones that are less than. Okay, so what I want to do is I want to start with the equal sign. So if you have an original problem that has an equal sign, what it's going to turn into is it's going to turn into an OR problem. So all of these absolute value inequalities, you're going to have to split them into two problems. So once you do that, you're going to have to decide is it and or. So hopefully this chart you can use as a reference when you're working out the problems so that you can figure that out, okay? So if you get an equal sign, it splits into an or problem, and basically what happens is you put the or in the middle, as you can see here in the second box, and what you're going to do is you're just going to rewrite the first part of it is just rewriting the original problem but without the absolute values. So if you see this x equals 3 is the same thing as the thing in the original problem, I just have no absolute value bars on it. And then on the other side, you're going to have x equals, and you're going to take the opposite sign. So one's going to be the original problem, the other one's going to be the opposite sign. Okay, so in this case, I have x equals 3 is what I started with, and so my other side is going to be x equals negative 3. My final answer is going to be still an OR problem. Since it's OR, remember, we don't have to sandwich it, and so it's just going to stay whatever you solve it out to be. And the graph for this, when it's an equal sign, is just going to be two closed dots, no shading. Okay. Moving on here, I have now in the second row, first box, I have the absolute value of x is greater than 3. So here's my little trick. I know it's really cheesy to do it this way, but like I said, you got to decide if it's an and or an or problem. So if you read this out loud, we have the absolute value of x is greater than 3. Okay, so my trick for you is it's a greater than, but instead of a great ER at the end, I'm going to change it to an OR at the end. So it's a greater than 3. So that's a way to kind of remember it, even though, again, I said it's really kind of corny. But here we go. So in how I set it up, it's an OR problem, so I put an OR in the middle. Just like what we did above, the first thing is just rewriting the original problem with no absolute values. And then the second thing is, yes, you're still going to take the opposite sign, but you're also going to flip the inequality the other way. So see how this one is greater than? On the other side I have it less than. Here I have positive 3, the other one I have negative 3. So you want to get all the different kinds of combinations pretty much. Okay. Final answer, it's still OR, so we don't have to do a sandwich or anything. We don't sandwich when it's OR. And when we graph it, just like how we did, you take your two answers. Since these were not the ones that have the little line underneath for the equal to, they're open circles, and any OR graph, just like any OR graph, you shade away. And so this is just a little note here, the little star. It says we would use closed dots if it looked like this, where it had the little line underneath. Okay, so just be mindful of that. Last one here, you could also get one that looks like this. So I have the absolute value of x is less than 3. So my memory thing here for you is less than 3. Okay, so the absolute value of x is less than 3. And so this is an AND problem. And again, just like how we always set this up, first thing is going to be just rewriting the problem with no absolute values. The second thing is going to flip the inequality the other direction and then change the number to the opposite sign. Final answer needs to be sandwiched, so don't forget you can't have and in your final answer when it's an and problem. And then just like all AND graphs, we're going to put our two dots, in this case open, because we didn't have the equal to signs underneath. So open circles shaded in between. And as a note, if you have closed dots, if you end up with something like this with the line underneath. Okay, so what I want to do is I just want to practice with these, give you a few problems to show you how to work this out. Here we go. So here's our first problem. The absolute value of r plus 4 equals 1. Another side note you guys need to be aware of is when we're solving for these absolute values, before we can even start the problem, we have to make sure there's nothing around the absolute value. There can be extra stuff inside it, but we can't have like numbers around it. So we can't have things that are going to look like let's see, x plus 1 minus 3 equals 2. We can't have things like this minus 3 on the outside, so it just has to be the plain absolute value. So before looking at number 1, my absolute value of r plus 4 equals 1, we are okay to go because the plus 4 is inside the absolute value, so we can continue with the problem. Okay, let me put this up so we can see this. So my problem is an equal sign, which means it's going to be or. So I'm going to put my little or here. And remember, the left side is just rewriting the problem, no absolute values. Rewriting problem, no absolute values. And then the other side is rewriting what's in the absolute value, rewriting the equals, but instead of, we're going to take the opposite sign of the number, okay, which will be -1. And then all you do is here's your two sets and you just solve this just like we have been. So I'm going to minus 4 r equals -3 minus 4 r equals -5. So I've gotten my two things. My final answer is okay to have or there, so this is good. R equals -3 or r equals -5. Last thing is to graph. So here is my -5, here is my -3, and then when we graph, I go up here, close circles on both of those. Okay, so closed, closed. So my final answer for these are going to be this whole thing, the graph and the two numbers that we got when we solved. Okay. Number 2, here we go. So first thing, let's check and make sure there's nothing around the radical. I got a +3, but it's inside, so it looks like we're pretty good to go. So let's figure out if this is an and or problem. So this is x plus 3. Absolute value of x plus 3 is less than 3. So less than, so it's an and problem. Okay, so again, rewrite the problem just the way it looks, but no absolute values. And then on this side, I'm going to rewrite what's inside the absolute value, but I'm going to flip the inequality the other way, so it's going to be greater than, and then change the sign of the thing on the number on the other side. So make it -3, and then we just solve. And then I -3, -3. So it looks like that. Okay, so I've done the second box. Third box, oops, can't have an and in my final answer, so I'm going to have to sandwich this. So my x goes here, and you guys should be sandwich pros now. Alligator's eating the 0, so alligator's eating the 0 on that side. And then -6 would have to go here. Graph. Okay, so I go -6. Here's my 0. And then I'm going to use a different color so we could see this here. Since they have the line underneath, they're both going to be closed dots. And since it's an and problem, we are going to shade in between. And so final answer for this would be the sandwiched answer and the graph. Okay, so it just looks just like that. Alright, so let's go to this one. I actually didn't even put another number on there. Let's make this absolute value of y minus 3 is greater than 2. Okay, so let's do our check. Nothing around the absolute value, so I can continue with the problem. And then circle this. I have greater, so it's an or. Okay, so let's set this up. I have an or problem. I'm going to put or right there. Left side, just rewrite it the way it looks. No absolute value. Right side, y minus 3. Flip the greater than to make it less than, and then change that 2 to a negative. And then we just solve this out. Okay, so I'm going to add 3. So this side I have y is greater than 5. Drop my or down. And then I have plus 3, and then I have, so y is less than 1. Okay, and since this is an or problem, I don't have to sandwich. I can just leave it as or, so I can go straight to the graph now. Graph, so I have 1, I have 5, and then these are going to be open circles since they don't have the equal to sign underneath. And then or graphs we shade away. So final answer is going to include the 2 numbers I solved for and then the graph. Okay, so those are the basic ones right there. And what I want to do now is go over with you some of the more involved versions of these problems. So here's number 4, and why I'm saying this is involved is because if you look at this, I have stuff now around the absolute value, and that's not okay. So what we're going to need to do is we're going to need to get rid of it. So even though it has absolute values on the x, treat it as if it didn't. So how would I get rid of all the stuff around it normally if it looked like this? Okay, so you know that if that was what the problem would be, I would add 2 on both sides. So I'd end up with 3. I still have that x there is greater or equal to 5. Now I have to get rid of this 3 that's in front, so we're dividing. And we're dividing. Okay. And, oh, what am I doing? 7 plus 2 isn't 5. It's 9. I was like, why is this going to be a fraction? Okay, now we divide 3. Divide 3. Divide 3. So I have absolute value of x is greater or equal to 3. And now that I've gotten rid of all of that stuff around the absolute value, I can continue with the problem now. Okay, so let's continue with this problem. So I have a greater than, so it's an or, greater than. So first half is just rewriting this the way it looks. Second half is rewriting this inside the absolute value, switching the inequality, and then taking the opposite sign of the number. And then all we do now is, because it's an or, I don't have to sandwich, so I can go straight to the graph. And so I have -3, I have +3. They have the lines underneath, so they're going to be closed circles. It's an or problem, so they get shaded away. And so final answer for this would look like this. Oops. Here, here, and then here. Okay. All right. So let's go to number 5, last one. So again, I have this issue again where I have things around the absolute value. The first thing that is a problem is the 6. Okay. So let's go ahead and get rid of that 6. Let's subtract it on both sides. Ooh, that is not a straight line. So subtract it on both sides. So these 6's are gone. I still have this negative absolute value of 2 minus p. And then I have less than or equal to -2. My second problem now is that I have this negative right here in front of the radical, in front of the absolute value, and I cannot have a negative there either. It has to just be a straight absolute value, not negative. So to get rid of that, what I can do is divide both sides by -1. And so those negatives are gone, and so what I have now left is 2 minus p, and an absolute value is less than or equal to +2. And so all I do now is I've gotten rid of everything around the radical, so I can continue with the problem. So let's figure out what kind of problem it is. So looking at my little symbol, inequality symbol here, it's the absolute value of 2 minus p is less than 2. So it's an and problem. Set it up. So first half, just rewrite without the absolute values. Second half, I still write the 2 minus p, but I flip the inequality. and then make that 2 negative. So all we do now is solve. So let's get rid of this 2 by subtracting it over. Negative p is less than or equal to 0, which means regular p is going to still be less than or equal to 0. Let's drop that and down. If I go on this side, minus 2, minus 2. So I have negative p is greater than or equal to negative 4, but I don't care about what negative p is. I want to know what positive p is. So if you want to get rid of that, here we go. Let's divide both sides by negative, which will give me now, instead of a negative 4, what am I going to have? I'm going to have a positive 4. Okay. I'm almost okay, but my final answer, I cannot have a and in there. Remember, I got to sandwich it. Let me continue this right here so I have a little more space. So my p goes in the middle, and then let's figure out how to sandwich this. Alligator is eating what number? Alligator's eating the 0 this time. Okay, so if alligator's eating the 0, I have 0 here, and then I have 4 here. So we graph this out now. I have 0, I have 4, closed circles, and then since it's an and problem, I shade in between, and then here's my final answer. Okay, so that's pretty much it, the absolute values with inequalities. Please write down any questions you guys might have, and don't forget to take the quiz.